Okay, you have to know that we have some notes. The first one is the molecule are very tiny and can't be seen by the naked eye or by the microscope. The second one, the molecule of one substance are the same in properties, but they differ from one substance to another, and this is very important note. The third one is the molecule composed of structural unit that called atom. The molecule composed of the smallest part of it, which is called the atom. And you have to know that there is a difference of the molecule of various substances. This is due to the difference in number of atoms, the kind of atom, and the way of atomic combination. That's why there is a difference between the water molecule and the ammonia molecule, for example. Okay, now you have to know that there are kinds of molecule, two kinds of molecule. The first one is the element molecule, and the second one is the compound molecule. So if I ask a question for you, complete, there is two kinds of molecule, dots and dots, element molecule and compound molecule. Okay, before starting what's meant by the element molecule, you have to know, like you know before, that the molecule consists of atoms. Okay, so the question now, what's meant by element molecule? The element molecule is formed of similar atoms, one atom or more, that combine together. So the element molecule is a molecule, but consists or formed of similar atoms together, one atom or more. Now you have to know what's meant by the element. The element, it is the simplest pure form of matter that can't be analyzed into simpler form or by simple chemical methods. For example, if I have an iron chair, so the simplest pure form of the chair that is made from the iron. So the iron is the simplest pure form of the matter. So if I ask you a scientific term question, it is the simplest pure form of matter that can be analyzed into simpler form by simple chemical methods. It will be the element. Take care of the word simplest pure. If you see it, it will be element. Okay, we said that the element molecule may be consist of one atom or more than one atom, but they must be similar. So the element molecule that consists of one atom only will be called monoatomic molecule. The word mono means one. So the monoatomic molecule, it is the element molecule that formed of only one atom. And the element molecule that formed of two atoms will be called diatomic molecule. The word di means two. So the diatomic molecule, it is the element molecule that formed of two atoms. Okay, we have some examples on the monoatomic molecule. We have example on the liquid state, that will be the mercury. The mercury, it is a monoatomic liquid molecule. And we have some example on gas. You have to know that all noble gases or the inert gases are monoatomic molecule. Why? Because they consist only of one atom. Example on the noble gases: helium, argon, neon, krypton, xenon, radon. Okay, so for example, if I ask, give reason question, give reason. Helium is a monoatomic molecule. Why? Because it formed only one atom. Okay, we have some example on the diatomic molecule in the liquid state, which is the bromine. Bromine is a liquid diatomic molecule. We have again some example on the diatomic molecule in the gas state. You have to know that all active gases are diatomic molecule, like oxygen, nitrogen, hydrogen, chlorine, fluorine. For example, the oxygen is written O2. Why 2? Because it consists of two atoms, diatomic molecule. But for example, in helium, it is a monoatomic. So it can be written He, not He2. Why? Because helium is monoatomic, consists only of one atom, He. Okay, we have here some notes. The first one, take care, mercury is monoatomic liquid. And like you see here, it can be written Hg. Why Hg? Hg only without numbers, because it's monoatomic, consists only of one atom. And you have to know too that the bromine is diatomic liquid element. And if you see here Br2, bromine can be written B capital R small 2. Why 2? Because it is a diatomic molecule, consists of two atoms. You have to know that the molecule of noble gases, all the molecule of noble gases are monoatomic molecule, like helium He, neon Ne, argon Ar. And take care too that the molecule of active gases are diatomic. All the molecule of active gases are diatomic, like O2, oxygen, N2, nitrogen, H2, hydrogen. Okay, now let's talk about the second kind of the molecules, which is a compound molecule. But before speaking about the compound molecule, let's revise the element molecule. We said that the element molecule, it is a molecule that consists of similar atoms, one atom or more. The difference here in the compound molecule, that here the compound molecule is formed of different atoms, not similar in the element molecule here of different atoms that combined together. So what's meant by compound molecule? The compound molecule is formed of different atoms that combine together. Now you have to know what's meant by the compound. The compound is a substance which is formed from the combination of two atoms or more of different elements with a constant ratios. For example, the water. Can anyone tell me the symbol of the water from the previous year, Engineer 6? Water can be written H2O. H2O. Here we have two atoms of H, two atoms of H of the hydrogen, and one atom of oxygen. So here we have more than atom of different elements. We have atom of the oxygen and the hydrogen, and combine together to give me the water molecule. Now we have some examples on the compounds. Like we said, we have the first compound, which is the water molecule, or you can write it H2O. If you look here, how many atoms we have? We have 3 atoms, 2 of hydrogen and 1 of oxygen. So the total number of atoms will be 3 atoms. 3 atoms of what? Of how many elements? Of 2 elements, the hydrogen and oxygen. So here we have 3 atoms of 2 different elements, 2 from hydrogen and 1 from oxygen. The second example is the sodium chloride. Sodium chloride, or you can write it Na, the symbol of the sodium, and Cl is the symbol of the chlorine. But if you remember, I told you that when the chlorine combined with another element, it must be written chloride, not chlorine. So it called sodium chloride, not sodium chlorine. So you can write the sodium chloride by NaCl. Okay, how many atoms we have here? We have 2 atoms, 1 atom of Na and 1 atom of Cl, 1 atom of sodium and 1 atom of chlorine. So we have 2 atoms of 2 different elements. The third example here is ammonia. Ammonia can be written NH3, NH3, and nitrogen, H hydrogen. So how many atoms we have here? We have 4 atoms. 1 atom of nitrogen and 3 atoms of hydrogen. So we have here 4 atoms of 2 different elements. 4 atoms of 2 different elements, which are the nitrogen and hydrogen. And the fourth example here is the hydrogen chloride compound. The hydrogen chloride can be written HCl. If you see here, hydrogen and chlorine combined together, hydrogen chloride. So how many atoms we have here? We have 2 atoms of 2 different elements, 1 atom of hydrogen and 1 atom of chlorine. And take care, we have some notes here. The first one, that the water molecule consists of 3 atoms, 2 from hydrogen and 1 from oxygen. The sodium chloride molecule consists of 2 atoms, 1 sodium atom and 1 chlorine atom. The ammonia molecule consists of 4 atoms, 3 hydrogen atoms and 1 nitrogen atom. And here we have a comparison table between the element and compound from the definition, atoms, and example. Let's begin by the element. The element, it is the simplest pure form that can't be analyzed chemically into simpler form by simple chemical methods. The compound, it is a substance that's formed from the combination of atoms of 2 or more different elements with a constant weight ratios. Atoms, the element is formed of similar atoms that combine together, 1 atom or more. The compound, the element is compound is formed of different atoms that combined together. Example of the hydrogen, oxygen, sulfur, aluminum. An example on compound water, hydrogen chloride, carbon dioxide, and ammonia. We have another table here about the chemical activity and their examples. The first one is talking about the very active metals that they react with oxygen when they exposed to humid air like sodium and potassium, and the less active metals, they react with oxygen if they are left in air for some days, such as iron, aluminum, and copper. And finally, the inactive metals that they find great difficulty to react with oxygen, like silver, gold, and nickel, and platinum, and chromium.